Hello, everyone. Hope all of you are keeping safe and well. My name is Dushyant Priyadarshee. I work for New Day in London. And in this talk, I'm going to try share my learnings about how to deploy and maintain financial software estate on Azure. Um, so the main objective of this talk is I joined recently. So New Day, the company I joined recently, by recently I mean 1.5 years ago. But in this 1.5 years, I have been privileged to be part of a highly talented team, as well as I get to work with a great talent pool across multiple teams. I've learned a lot about how a big enterprise operates, how they maintain, how we deploy and maintain Azure resources on cloud, mainly Azure. So I want to share the learnings with the community. And in return, I'm hoping we can gather some feedback. Maybe I didn't explain something, you can ask questions around it. Maybe you do something that we do, but you do it differently, then please suggest new ideas. So hopefully it triggers a discussion and we can learn more on how to improve things. Uh, so that sets the scene. So let's talk a bit about the company I work for. The name is New Day. We're based in London. And so on the left here are our products. So essentially, we are, sorry, I missed a bit, is that we are a consumer credit provider. So we provide credit cards. On the left side are the products which we directly provide to consumers like BIP, Aqua, Fluid, and Marbles and Opus. So these are credit cards provided straight by NewDay. We also work with retail partners. If any of you have a credit card from Amazon or Burton or Debenhams, you would probably know that NewDay is a lender. So we are in financial market, financial industry. A bit about the manifesto. New Day's manifesto is helping people move forward with credit, and that's central of everything we do. The whole organization works around this idea. And the main points which we focus in a manifesto are welcoming. So we would like to say yes, although responsibly, to any new credit card applications. So we will do our research. We'll try to understand that this person will be able to pay back. So we have to responsibly say yes. We have to be understanding. And especially during the pandemic, New Day took steps to make sure anyone who's struggling is able to pay back or gets a holiday. And we do provide solutions on how to build credit. Knowing we need to know our customers so that with our expertise in credit, analytics, and software, we can help our customers build their credit over time. And also rewarding. So in return, we reward our customers when they are good with managing credit. In return, we provide, say, lowering of APR, loyalty benefits, and many other ways of rewarding good behavior, good credit behavior from our customers. This bit is a slide full of numbers, but this is just to highlight the growth of the company. So over the last year after year, we're growing almost 20%. And there's a lot of numbers, but if you just highlight on the top right here, in 2020, we issued 19% of credit cards in the UK, which is quite a big number. And on the lower left here, we are recognized in the finance industry as quite a big player in the credit card industry. The middle numbers here, we're quite proud of these. So the amount we donate to charity, our number of complaints, which is very less per 1,000 active accounts and 0 incidents. Plus, we are trying to do our bit towards bringing in more equality in the software industry. The lower numbers here are roughly showing 5 million to 6 million customers we have active credit cards in the UK right now. So these few slides was just to build on what New Day is and what we do. And hopefully that is building up to the idea that even though we are quite a big company, do we have challenges as a financial software company? And yes, we do. And because it's a technical talk, we'll focus mostly on the technical challenges and not on the non-technical ones, maybe few non-technical ones. The first one, like any other financial software company out there, security is one of the top technical challenges we deal with day in and day out. So we need to stay on top of security issues. We need to meet compliance requirements while maintaining a healthy development productivity. It is quite difficult. We need to lock down our systems. We need to make sure it's it's not easy to change things because we are to reduce the vulnerability, but at the same time, we need to make sure development productivity does not take a hit. Cultural shift. Maybe in 1950s and 60s, it was okay for banks and financial institutions to lock down and be isolated. But now we need to adopt automation, cloud technologies, DevOps, DevSecOps. That's because other players in the finance industry are doing it. So we need to be top of our game, have all these in place, and still be secured. The next one being regulatory compliance. So in regulatory compliance, there is something called PCI DSS, which many of you probably already know, but I'll just quickly explain that. So PCI is Payment Card Industry, DSS is Data Security Standard. So it's a set of regulatory compliance requirements that we have to meet to be recognized as a compliant or financial software in the industry, software company, sorry. And one of the downsides of not being compliant is obviously our software may not be up to the marks, may not be good enough. But on the top of that, the FCA can impose a fine on us for up to $100,000 a month, which is quite a big number for any software industry or any company in general to lose. And instead, we choose not to, not to be non-compliant. So we put in quite a lot of effort into our compliance and security setup throughout software products. The last one of technical challenges is continuous innovation. We need to, it's sort of related to the cultural shift, but continuous innovation is more about how we need to adopt new technology like apps, mobile apps, chatbots, artificial intelligence, data science, to provide better solutions to our customers. On that note, I would like to point out BIP is one of the products that we launched recently, and it's the first of its kind in UK, where the credit card, well, it's not a real credit card, rather it's a mobile app, which is a credit offering. So those kind of things, along with compliance, we need to be FCA authorized to do those kind of things. So it needs continuous innovation to do this. While understanding these technical challenges, one of the things that we decided a few years ago as a company that we will choose Azure as our main cloud cloud as platform. So all our products and services are currently hosted on Azure Cloud. And today we have 30 plus Azure services. So all the icons here are Azure services, which we are currently using. Well, actually a subset of the services. We use quite a lot more than that. So we are using 30 plus services, all of them working in one single virtual environment. And the whole system and every single resource in that system is PCI DSS compliant. Along with that, we are moving more and more towards automation. So we have automated a majority, a big part of the whole system, but I don't think, well, we don't think that we are 100% there. So we are still working towards it. And it's very essential. It is really needed because if you see at the scale that we operate, we currently have 8,000 resources roughly in total, and of them, 3,000 are running actively in production. And at any point in time, we are managing about 20 plus Azure subscriptions. So at that scale, it's really important that we have automation in place to reduce human interaction, to reduce human errors, and make sure things run smoothly and let the machine do something that it is good at and not us. On that point, again, PCI DSS compliant, we cannot guarantee compliance of all these resources without automation. So it is really important we try to meet 100% automation over time. So how do we do it? How do we manage resources at that scale? Many of you probably have already guessed. The answer would be simple, that is CI/CD. At New Day, we use TeamCity for our CI, for our builds and tests, and Octopus Deploy for our deployments. But is that all we need? Maybe not. So this is where the team I work in steps in. So I work in the platform engineering team. And what we do is we work as a service provider or a consultancy for rest of the organization. So we liaise with multiple teams. So on the left here, if you see there are multiple teams like security, networking, incident management, and few other teams, business and others. So we liaise with all of them and we prepare solutions which will enable our, say, development and testing teams. So a pool, because we have 30 odd development testing teams. So we provide them solutions so that they can deliver value to our customers. And so being part of this team, it's a position of privilege because we get to work with so many different teams. We liaise with so many different teams. We also gather feedback and learnings from development testing teams. And the team itself is quite diverse. So we have SREs, we have ops engineers, we have DBAs, devs, developers, network engineers. So it's a constant learning environment, and we get to provide solutions so we can deliver value to the customer via the development teams. Although it does get quite difficult when we want to be a cross-functional Scrum team. So there are challenges, but that's how this team operates. From now on, we'll try to see how the platform engineering team helps with deploy and maintenance of the Azure infrastructure. How do we build? So this is what I'm talking about, how do we build and test our software. Like I said, we have 30 odd development teams. All of them are using different technologies, .NET, JavaScript, React, many other technologies are being used. So we do not directly do things for these teams. Rather, we, as the platform engineering team, we own and maintain the team city infrastructure. So the team city infrastructure was decided a few years ago will be hosted in our Azure infrastructure so that we keep the data with us. So currently, these are virtual machines on Azure, the infrastructure as a service, and it's platform engineering team's responsibility to update them, patch them, and maintain them. We design build and test templates, including security test templates. So what these templates do is any team that's creating a new product or maybe an existing product, all they have to do is they clone these templates and build and test and prepare a NuGet package or an NPM package. So what that does is it goes through all our standard testing and build process, and hopefully saves the development teams time from having to do all these pipelines themselves. So it's our responsibility as the platform engineering team to build, design these templates and keep them up to date. The point of this talk is more about how do we deploy and maintain. So we'll not go more into details of how we build and test. Rather, we go more into how do we deploy. So this is what I touched on shortly before, is that the Octopus Deploy is our main deployment technology, and the platform engineering team owns and maintains the Octopus Deploy infrastructure. It's the same idea as TeamCity. We own the IAC, or sorry, infrastructure service, Azure VMs of Octopus and its tentacles, and we maintain it, patch it, update it, and all those things. But at top of that, we do something called deployment templates. In the same lines as build templates, we design deployment templates. And what deployment templates do is, if you remember, I touched on the idea that the platform engineering team liaises with so many different teams, the networking team, security team, and many other teams. So we take all of the requirements into consideration, including the business, including development teams and testing teams, and we design deployment templates. So what happens is this word cloud. So this word cloud is a subset of all the features that all the development teams get when they use one of our deployment templates. So because we have liaised with the networking team, we understand what their requirements are and what they would recommend. And so anything that dev teams deploy will already be VNet integrated. We will, because the business needs in a certain way, naming convention will be there. And we will have ingress control, PCI compliance, because the compliance team would require us to do that. So all these values will be in place of for deployments. So any team deploying using our deployments to Azure is already ready to go to production because they have already met all the compliance and security requirements and many other requirements, including, say, cost effective or not. So we try to bring the cost down in the deployment templates itself. We will go a bit into how we do that. But before that, we'll go through the general architecture of the deployments. Sorry. So in general, the architecture, we are depending on serverless, mainly Azure functions. So majority of our deployments, the backend will be Azure functions, and we also have web apps. So the idea here was that we did not want to support the operation side of things. And that's why we avoided going via, say, Kubernetes. If you know about Atlassian, they had to develop Escalator because the scaling by default with Kubernetes is not as good at this scale. And hence, after a lot of investigation, we decided to go with just Azure Functions and serverless architecture. Carrying on with general architecture, any public-facing web app, we have front door in the front. So what happens is we have the same web app deployed in multiple regions, and we have a front door in the front. So any request coming in is split across because these are active. So both of them running at the same time. So we try to split the traffic on the base of 50-50 or depending on what we need at the point in time. So we split across 2 regions, and these resources talk to this Cosmos DB, which is globally distributed across 2 regions as well. Sorry. If you remember, again, the deployment templates, we already enforce the idea of disaster ready. So any resource being deployed will be forced to become disaster ready by being in 2 different regions and having a front door in the front. That's for public web apps. Any public facing API, like we provide open banking API. So if we use apps like which gives you Yolt, for example, which give you, say, how much you're spending, when you're spending, what you're spending on. So these kind of apps, they need open banking API to connect to our systems and gather your resources, your transaction details. So that's something, obviously, with your permission. That's how they operate, but they need public-facing APIs like open banking. So we designed our open banking API with Azure Functions, and we have APM in the front. And again, the whole thing is distributed and disaster ready. So if, say, one region goes down, the other region keeps on serving requests. Also part of general architecture for data storage, we use Cosmos DB and Azure SQL Server. For Cosmos DB, we use replication across 2 regions or sometimes multiple regions to make sure, like, if any region goes down for some reason, the other region continues to process requests. And the same idea for Azure SQL Server. We use failover groups for that. Essentially, the point I'm trying to make is that all our deployments and all the resources that we deploy to our Azure subscriptions, they are already disaster ready because resilience is one of the KPIs that we want to improve on. So we are currently around 99% resilient, 99% available, but we want to meet 99.99%. And that's why we are putting all these things in place, checks in place. And all these checks will be placed much before production, like in user acceptance testing level, for example. And at that point, we will be able to see and do our failover testing as well if we wanted to, before we go to production, and make sure every team is following this pattern of disaster readiness. The way we do all these deployments is Terraform. So Terraform is our main infrastructure as code solution. And what we do, we follow this model where Terraform code is only in the platform engineering repo. So the platform engineering team owns this repository full of Terraform modules and even the main Terraform app, in Terraform file, sorry. And what we do is we get all of them packaged into a NuGet package, and we send it to Octopus. And at Octopus deploy, development teams can set infrastructure settings and control what they need. So we will go a bit into that in subsequent slides. But what happens is you control what you need from Octopus, not Terraform. And you can set values like, I need a storage account, I need a function app, maybe I need a Cosmos DB. So all those values are set, and Octopus just deploys those resources onto Azure. So Terraform has served as well. New Day has been one of the early adopters of Terraform, but we do have some pros and cons. With Terraform, the pros are the documentation is very good. So it's really easy to find out what they support and what they do not. Microsoft's Azure provider is also quite good, and it's quite easy to figure out what's going on there. We can unit test with TerraTest. We can security test using TFSec. SNCC has started providing security testing for Terraform as well. But in the same time, we have a few cons. State files is the main con. State files have a purpose. They help reduce the latency of calling Azure every time you do a refresh, or you do not refresh, you do a plan, or you want to see what's in the state file. Also, it gives you the desired state functionality. Like, you don't want a certain resource, you need to make sure it's not in your state, and it will get removed from the resource on Azure. But in the same time, state files can be a con. It's a major problem when you have modules and you want to rename the modules. Then Terraform sees that being a deletion, and it will go ahead and destroy resources. So we really, really do not want our resources destroyed, mainly in production, not even before that. And that's why we're looking for solutions around it. And that's why this con is listed. The second con is the delay in getting latest Azure features. With Terraform, we have noticed many times that we do not get what we want immediately. So there is a latency between when Azure releases a feature by the time it comes to Terraform. And New Day continuously tries to adopt new technology and try to go to production as soon as possible, as soon as we can get it to test and verify. So for that case, what we do is we use PowerShell scripts to work outside of Terraform, which is, again, we'll touch as we proceed with this talk. The other thing you possibly have already noticed is IAC abstraction. So when I said the platform engineering team owns the Terraform code, meaning we just ship the NuGet package, and only the values set via Octopus or a JSON file are the values that we consume and deploy the resources. So what that means is that development teams, so when I was talking to 30 or development teams and testing teams, they won't see the Terraform code. They can see in a repo if they wanted to, but they won't necessarily see during their work, during the deployment process. What they will see is that they have to set these values. So take this example. What's happening here is, this is the Terraform code in the NuGet package. So we are saying, create a storage account. And if these values are set via Octopus, where you are saying, I need one instance of storage account, and this is the name of my storage, and this is the resource group, and whose location I'm deploying to, then our NuGet package will consume this JSON, which is a set of values, and it will just make sure that this module gets deployed with these values, meaning it'll be one instance of storage account, one resource group, location being West Europe, but the last one here, you see, is blob public access. So they haven't set public access. And in this case, we fall back to our default being false. So what we are doing here is we are letting users, or our developers in this case, say that they would need public access if they wanted to by saying true in the values, but if they do not, by default, we can set it to false. So we have abstracted out Terraform, but at the same time, you can deploy and get the resources that you need without having to learn Terraform. The idea being, so in pros and cons, the idea being the ease of onboarding. If there are any managers or recruiters in this group, you probably will know it's already difficult to find somebody with a cloud technologies, C#, .NET, and few other skills. On top of that, if you are looking for IAC, it does get quite difficult. So a few years ago, we decided on going with this idea of IAC abstraction, where all you need to do is set values in a JSON file or in Octopus deployment, set the values as numbers, strings, and then you get your resources that you want. So the ease of onboarding reduces the learning curve for multiple development teams. The ownership remains with one team. So platform engineering team is the only team who owns, maintains, updates, and fixes, take responsibility of all the modules and all the resources. And also we can enforce some of the defaults as well as some of the rules, like what should the naming convention be, what should the tagging convention be. So all those we can enforce using these kind of modules. The cons being, again, state files. Terraform state files are an issue. The problem, again, in this case will be, if, say, for some reason, I want to rename my storage account to not my storage account, it will go ahead and destroy storage account for many development teams. So it becomes very difficult to change a module when we have so many people using it at the same time. The second con being rigidity, because we have abstracted out, if any team wants to do bespoke changes, if, say, they are working on a proof of concept, it gets very difficult for them to use all these modules and deploy those bespoke changes without, obviously, the platform engineering team support. And hence, we are considering a possible future for ISC, what we are thinking is we have a proof of concept going on for Azure Bicep as well as Pulumi. We like Azure Bicep because it's like the new version of ARM templates, as well as it has no state files, thank God. And so what we are planning is platform engineering team can create these modules publish them into a repo. In case of Bicep, we could publish into ACR, the Azure Container Registry, and multiple product teams or development teams can consume them and have our Bicep file in their repo, like the main Bicep in the repo, and they consume the packages, and they can deploy the resources straight from Octopus using Bicep. The advantage being it's less stringent. They have more independence, more flexibility. If, say, we do not provide certain module, they can use the default Azure modules as well. And this should work, given that we are an Azure house. So that's a possible future. We are investigating more into it. We're also looking at Pulumi, and we do have multiple teams who like Pulumi, and we're going to try that out as well. The next bit about deployments is custom step templates. If you remember, I was saying with Terraform, we do not always get the latest features. In those cases, we use PowerShell. So in Octopus, step templates are certain steps which we can create using PowerShell scripts, and that can be shared across the organization, and multiple teams can use one step template, for example. So what the platform engineering team does is that we design and maintain these step templates in our repos, create NuGet packages, and these are consumed by Octopus and shared across multiple teams. So we use Azure CLI and Azure PowerShell to write our scripts. So whenever, say, for example, when Terraform did not support app configuration, we implemented that using Azure CLI so that development teams do not get blocked. They can just use one of the step templates in their deployment and carry on. So that's more or less about deployments. The next bit is how do we maintain this infrastructure? So for maintaining, we use many of the native Azure features or services, as well as some services that we have designed ourselves. First is Azure policies, which you all have possibly already guessed. We already enforce many of the policies via Terraform, like what are the naming conventions, what are the tagging conventions, and what are the security requirements. Many of these are already enforced by Terraform. But there could be teams who can deploy outside of Terraform. Maybe a team likes ARM templates, maybe somebody likes Pulumi, they could deploy using that. So for that reason, we also have Azure policies in place to enforce the right tagging region, because it's very important that we don't put our resources in regions that we're not allowed, or outside of the regions we are allowed, mainly for GDPR concerns, and as well as security. So we enforce these using Azure policies. The other service we use, Power BI, for our cost reporting. So this depends heavily on resource tagging. So when we are deploying resources from our Terraform modules, we have already enforced tagging. And part of the tagging enforcement is that at the point of deployment, you have to set which team you're deploying from. So you know the resource belongs to this team. Sometimes the person's name as well, or the email ID. And the tags would also have, say, when was it deployed, and when is, and many other metadata about the resource. On the basis of these, like the team, like the when was it deployed, on the basis of that, we create classifications so that we know which team is deploying resources in a very cost-effective manner. And maybe some team is not doing. So how can the platform engineering team go and help them reduce the cost of their deployments? And Power BI gives us like a big, like a grand overview of the overall resource expenses of the whole company. The next service is Wreck-It Ralph. So we have, so a Wreck-It Ralph is essentially a automation account, a PowerShell script. So its job is to go ahead and destroy non-production resources. The idea here being that, again, it depends on the resource tagging I was saying. So the idea here is that it checks when a resource was deployed on the basis of the tag. So when it was deployed, there'll be a tag saying deployment date. So from the deployment date, it will calculate when does the resource expire. So maybe in development environment, we'll set the resource expires in 2 days. Maybe in testing, some testing environments, 3 days, maybe some testing 2 weeks. So on the basis of some logic, Wreck-It Ralph figures out when does a resource expire. when it figures out the resource has expired, it has Teams integration, Microsoft Teams, so it inform that development team saying your resource is expired. So I'm tagging it with the demolition date, and I'll go ahead and destroy it on that date. And on that specific date, it will make sure it destroys the resources, removes the Terraform state files, so that teams can do a fresh deployment. The idea being, it is reducing cost for that team. It's making sure any resource that's not being used gets destroyed in non-development environments, as well as it is enforcing good continuous deployment practices. You may have teams or members who sometimes make manual changes to resources to get things to work. It's okay, but it gets quite difficult when we have to replicate the same set of resources as a platform for multiple of our clients. So for that reason, we need to make sure everything is automated and scripted. So if Wreck-It Ralph goes and destroys resources, many teams will have to write it as scripts and deployment and not necessarily do manual changes. The next service is not dull, but dynamic allow listing system. So what this is, maybe you possibly already know. So many resources like function apps, web apps, storage accounts, Cosmos DB, key vaults, many of these accounts, they can restrict which IPs or subnet IDs can access or send requests to them. So in this screenshot, it's a function app, and these are the access restrictions saying only these IPs are allowed to send requests to this function app. So with that logic, what we have done is we have a service in place, and all it does is in this environment, as in this example, let's say we have a function A. Then if function B comes in, then the dynamic allow listing system just adds the IPs of our internal system in function B, meaning function B now allows requests from here. But maybe these two need to talk to each other because they are in our subscription, in our environment. So the system will also add each other's IPs. And same way when function C comes, that also gets the IPs of other systems in our environment. So the idea is dynamic allow listing system is trying to create a mutual communication, or a system where resources can communicate with each other in one environment. And this is the overall architecture of how it roughly works. So it takes a config of what are the resources we want to deploy and who should be talking to who, and keeps them in Cosmos DB, and then triggers an update of the resources. It also has a static JSON file, which is like our internal new day IPs, which could be static IPs of our firewall. It could be IPs of our breakout IPs, for example. And it will make those changes to the resources we have provided in the config. There are two special cases. One being whenever a resource is scaled. So if, say, you have a P1 V2 function app and you scale it to P1 P3, or maybe you have standard and you scale to be premium. Those cases, it's very likely the outbound IPs will change. So if your function is trying to call some other function, that other function needs to know the IPs that it's coming from. And in those cases, we have event grid integration. And what event grid does, it tells us whenever scaling happens. And when we know about the resource that has changed, and then we trigger and apply the same set of rules that we already know. Or we generate new rules and apply, actually. The similar idea about resource deletion. So this access restriction on the basis of IPs and where the request originates from is a security as well as compliance requirement. So when a resource is deleted, those IPs should not be allowed anymore. We need to remove those IPs. For that, also, we do the same. We get event grid to tell us whenever a resource has been deleted. So if, say, function A is talking to function B, and function A has been deleted, then immediately we have to remove the IPs or the subnet ID of the function from the dependency. And that, again, event grid helps us. So this can get a bit complicated when I go ahead and explain it a bit more. But there's a link which I did last year at .NET Cambridge, this talk. So feel free to go through that if you want, if you're interested. So we'll just move on to the next service, which is CAT. Well, it's not a CAT. It is Certificate Automation Tool. So if you remember, when I started the talk, I was talking about the scale at which we operate. At that scale, with the number of certificates is quite a lot. So we are currently managing 300 odd certificates, meaning we need to make sure we know when any of them is about to expire, and we need to try to reduce our management on it. For that reason, we have created this service called Certificate Automation Tool. And that's an app service which has the rights to go ahead and read multiple resources and Octopus deploy to find out what certificate is being used where, what is the expiry date. So in the screenshot here, it's trying to find the domain name, what subscription it is located in, what resource it is bound to, and essentially, when does it expire? That is very important because we need to know. We use the certificate for, say, communication with multiple third parties. So if the certificate is expired, credit card payments will stop. Credit card, maybe application issuance will stop as well. So it's really critical for the business that these certificates remain intact. Sorry. So in the screenshot here, if you see that it shows multiple things, like on top right here, it shows us when we're not managing certificate, and it tries to encourage us to not manage. So what we do is, many of the front door certificates, we're trying to move towards Azure managed certificate, meaning we don't have to worry about expiring because Azure is managing it. And so the automation tool tries to encourage us to move towards that. And it will also show which are expiring soon. This is also a work in progress. We're trying to add more features, and we're trying to add features where hopefully we can soon generate certificates and update them without us having to manually trigger new builds. Currently, we have to update certificate and do a manual deployment to make sure that, not manual, like click the button on Octopus to make sure that their certificate gets updated. So that's more about maintenance, but we do have monitoring and alerting as well. Sorry, I missed that. About maintaining our infrastructure. App Insights, we have App Insights for all our function apps, web apps, and any other resources we're deploying. So we are constantly gathering telemetry to understand what's going on. If something is wrong, we have dashboards, Azure dashboards, as well as Grafana dashboards, where we try to predict, or we see the trend, not predict, but we can see a trend of things happening over time. And on the basis of the queries on App Insights, we have Azure alerting as well. So when these, say, for example, a front door is probably getting lots of 500s, for example, and that would trigger an alert for us. And those alerts can lead to incidents when we actually see that, yes, something is wrong. And then the incident management kicks in. And all these, so from Azure dashboards to incident management in this list, so these have traditionally been managed by the platform engineering team, but now we are slowly shifting left. We are encouraging and trying to help development teams take ownership of all these, like own the product end to end. But incident management has, again, like traditionally been platform engineering, but we're trying to help other teams also, like help wake up with us at 3 in.the morning and help try to fix or try to work around a problem that we have seen and got an alert about. Learnings. So these, the things that I went through, there are a few learnings that I wanted to share. The first will be ISC abstraction may not always work. We think it's a very good idea that we would like to bring down the learning curve, but at the same time, the rigidity makes it quite difficult. So we are looking at solutions, maybe sharing modules and getting teams to learn a bit of Azure Bicep is the way, or maybe a bit of Pulumi is the way. So we are working towards it. The second point is resource tagging is very useful. If you are using Azure or Google Cloud or AWS, any cloud that you like, if you're not tagging, please do. It is very useful. It will make your life much easier in the long run. The third one being resiliency is an ongoing process. Like I said, we have been aiming for 99.99% availability. We have issues at times. We have mitigated most of the issues. Many times we'd have to create incidents on our third parties. Maybe we made a deployment which went wrong, or let's say Microsoft has introduced a breaking change. So there is always challenges when we're trying to meet 99.99% resiliency. But it's an ongoing process, and I think we will get there. We're working on it. The next one is automate more. Again, the scale at which we operate, it's really difficult to do things manually. We need to automate as much as possible, reduce human error, reduce human interaction, and enforce good CI/CD practices. Bit of non-technical bits, learnings. Collaboration is the key. Anything that the platform engineering team does is, thankfully, we have multiple teams to help us. The security, networking, business, incident management. development teams and testing teams, they all help us to design these solutions so we can help them in return as well. So the collaboration, working multiple teams together is really, really important, really important to the success of the whole enterprise. The last learning, if I were to answer the most difficult challenge I've faced till now, is probably the cultural challenge, where it is a constant challenge to get, say, when we have new joiners, new teams joining even, to get them on board. Because we have already a system in place, which is quite restrictive, it gets very difficult to explain and get them on board to accept that there is a reason for it being this difficult. And for that reason, we are doing many show and tells demonstrations and answering lots of questions to try help reduce that cultural barrier of people accepting that PCI DSS compliant system can be quite difficult to work with. So what's next in our plans? First is better cost management. So we are trying to constantly bring the cost down of the overall infrastructure management, overall deployments into Azure. One of the things we're trying to find out and trying out now is multiple functions in a single premium app service. So instead of deploying one app service per function, we're trying to have one app service for multiple functions and trying to bring the cost down. Pipeline as code. So we use TeamCity, which I touched on before. TeamCity does provide a pipeline as code option, but we are not using it. So we are looking at GitHub Enterprise. So we are hoping to move to GitHub Enterprise soon and try using YAML-based pipelines. But that's again in the pipeline. We are also in the pipeline. We are trying to investigate and find out more about it. Azure Bicep, we are really amazed at what Azure Bicep is doing, the lack of state files, the good support from Microsoft. And we already have a Microsoft support plan in place because we are an Azure customer. So we are considering moving towards Bicep. The major next thing is the shift left. So we want to move towards a world where the development teams own a product end to end, right from the point of, say, requirements gathering to the point of deployment, maintenance, support. So we, as a platform engineering team, we are still providing the required consultancy and services needed to help every team meet that goal. We are also part of the organization, so we are helping them. But at the same time, the idea of security, certificate, maintenance, everything, incident management has to be more with the team, which understands it better. Because if we have to wake up 3 in the morning and we don't know how to fix it, it's a bit pointless. In conclusion, I think we have 41 minutes, so let's go into conclusion quickly. In conclusion, I must admit, in my 1.5 years at New Day, that deploying and maintaining financial software on cloud, I'm guessing any cloud, I've worked mostly with Azure cloud, is a complex affair. Although I must insist, it's a very exciting affair. The challenges every day are just nonstop, and there are many things that we think we have figured it out, but there are quite a lot of learnings and there's continuous improvement. And we know there are things that are what we think are really good will change very soon.